Suppose we have 2x squared minus x plus 4 divided by x cubed plus 4x. We want to split this into partial fractions. So first of all, the degree of the numerator and the denominator, they are different from each other. The degree of the denominator is equal to 3, which is more than the degree of the numerator, which is equal to 2. So no long division. In applying the method of partial fractions, let us break down the denominator into smaller pieces. Let us write x cubed plus 4x into factored 4. So x cubed plus 4x, if I factor out x, I get x squared plus 4. So I have a linear expression and I have a quadratic expression. Please pay attention, your quadratic expression cannot be written in factored form anymore. X squared plus 4 cannot be factored out into x plus 2 times x plus 2. This is a common mistake for students that they write x squared plus 4 as x plus 2 times x plus 2. This is equal to x plus 2 to the second power. It is not x squared plus 4. So be careful about this part. If you take a look at the discriminant, b squared minus 4ac for this quadratic expression, it is a negative value, b squared minus 4ac. Your b is equal to 0 minus 4 times 1 times 4, which is negative 16. It is negative. So you cannot write it in real factored form. So what should we do now? This is your third case when it comes to partial fractions. In case 3 for partial fractions, if you have px divided by qx, and q of x is equal to ax squared plus bx plus c, which is a quadratic expression and cannot be factored out. The partial fraction that we expect for this is ax plus b divided by this quadratic expression. Then the partial fraction is ax plus b divided by your ax squared plus bx plus c. So let's go back to our question. Our question is, you have 2x squared minus x plus 4 divided by x cubed plus 4x. So first of all, remember that your denominator is x times x squared plus 4. So we have to think about the linear expression as well. 2x squared minus x plus 4. So for the linear expression, let us use a quantity, a value. Let us use, for example, something like c, anything that you like, e, d. Let's use d divided by x plus. Now for the x squared plus 4 part, Let me use a different color because later on we're going to take common denominator. X squared plus 4, you have ax plus b. Now take the common denominator. Which is x times x squared plus 4. Okay, perfect. Let us begin. On the left-hand side, you have 2x squared minus x plus 4. And on the right-hand side, you have d times x squared plus 4 plus x times ax plus b. Very good. If you distribute d into parentheses and I distribute x into parentheses, you can simplify this further. This is equal to dx squared plus d times 4 or 4d plus ax squared plus bx. Very good. So you only have one linear term and one constant, and you have two quadratic terms. So the quadratic term on the left-hand side is 2x squared. The quadratic terms on the right-hand side are dx squared and ax squared. What's the meaning of that? It means that 2 must be equal to d plus a. D plus a. So far, so good. What else do we have? We know that 4d is equal to 4. Constants must be the same. So 4 is equal to 4 times d. Okay, it makes our life easy. Why is that? Because you can basically divide by 4 and calculate d. So d becomes 1. Okay, so when d is equal to 1, what's the meaning of a? A is equal to 2 minus 1 or just 1. Very good. We know that bx is equal to negative x. So b is equal to negative 1. Bx is equal to negative x, or negative 1 is equal to b, and you're done. So b is equal to negative 1. We found all the missing pieces. Let's go back to our partial fraction. Copy, paste down here, and simplify this as much as we can. So my d is equal to 1. My a is equal to 1 as well. And my b is negative 1. So here you get minus 1. So we separated our fraction into the summation of two partial fractions that is easy to work with.